I have access.
I'm Philipp Stiefel. I work with Access for a very long time, more than 20 years now. And I usually work with Access and SQL Server backends. So I'm actually not really an expert on Microsoft Access query performance. So what I will show today are rather universal approaches to improve query performance, and they will work basically with every database system. With that being said, we are right in the middle of the topic, and with Microsoft Access, there is actually one thing, and that is universal as well. There's one thing you should do to improve query performance, and that is you should make the database engine have to process as little data as possible. And that is, well, the basic foundation, and everything you do in performance tuning is basically built on top that very, very simple, simple statement. And well, in Microsoft Access, there are actually two things you can do to make the engine process less data. And that is the very first basic thing. You need to create indexes on your data. It's really, really basic. Everybody of you has heard that, but please keep it in mind and actually do it. And the next thing, and that is not as straightforward, is allow the database engine to actually use the indexes you created. And that is what we will talk about for some time now in a couple of demos here. So I've got this nice query editor prepared that is hopefully better readable than when I would just use the Microsoft Access query editor. I'm using the Northwind database here. So if you're familiar with the Northwind database, you can basically work along if you would like to. And it's just, yeah, something you probably know very well. And this includes these annoying fields with blanks in them or hyphens or whatever funny characters. And I absolutely discourage to use that in your database. I just haven't changed it from the default Northwind template. So they are all over the place, but I wouldn't recommend to do that. I just did it to make my samples work with the basic out-of-the-box Northwind database. So to the setup I use here for all the demos, this is a split database into a front-end application part and a back-end database part. And the backend database part is also on my local computer for most of the demos, except for this little one at the beginning. And here I will explain why I choose that setup with that local backend. So we will just run this query, and this goes to a backend database on a network. It's exactly the same customers table, but it sits on a network, and therefore I have renamed it to customer network. And here there is an index on the last name column. And whenever you see this screen flashing in green, then I'm executing the query, and you see the results down here. But that is not the really interesting part. The interesting part is this. This is the execution time of this query. And this is just a date diff in seconds that is will not be sufficiently well, not detailed enough. And therefore I added also the difference in ticks, which are milliseconds for the query execution. And so we see if there is an index on the database column we're looking for, it takes about 1.5 seconds to query like 200 records from a total of 200,000 customers in the backend table. And now I will kind of repeat this query on another table. It's an exact copy of that table, but it has no indexes, but it's also on a network share. And now it will run quite a little bit longer. And that is, I expect it to be finished in about 30 to 40 seconds, but we'll see. And that is very, very important to keep this difference in mind here, because this is the very first time we hit that table on the network share. And now the data needs to be read over the network, and it's basically the whole table that needs to be read because there is no index. And now you see it took 34 seconds to query this data. So it makes a huge difference to just have that index between 34 seconds and basically less than 2 seconds. But let's run this query on the non-index table again. And now it also takes only 1 second. It even appears to be faster than the other query, but you can also run the index query again, and it's even faster. And this is something you need to keep in mind with my samples I show here, but also you need to keep it in mind with testing your own databases for performance. Because if the database is on a network, the very first time you hit a table or a storage segment in the database, it will be very, very slow. If you repeat the very same query, it will be extremely fast. And that is something that has to do with network caching. It's not Microsoft Access. It's not database caching that is causing this. It's network caching. And this cache, I wasn't really able to figure out what this cache, where this cache lives, how you can control it, and how long it lasts. It usually will persist for about 5 to 10 minutes that the data remains cached, and then it will vanish from the cache. But it's really, really important that you always consider that when testing for performance, because your customer will not say, oh yeah, if the query is slow once, I run it again and then it's fast. The customer will complain about the first execution taking the 35 seconds. That is what's hurting your customer or your users. So, but because of this hard to quantify network caching mechanism, that is the reason why I do all my samples with a local backend database. Then the differences between bad and good queries will only be seconds or even a couple of milliseconds. So they are hard to notice and they seem to be totally trivial. But these differences will translate to 10, 20, or even 30 seconds if your database rests on a network share and is not cached locally. And you cannot really force this caching. It will disappear from time to time, and then everything becomes really, really slow. So this is just a bit of explanation here, and it's really important to keep that in mind when testing your own applications for performance. So I will shut down this database for a second, and just show you the backend database, a very small backend database. That's not the one I'm really using, just to show a couple of things about indexes. I guess most of you will know that, but nevertheless, I will show that. The standard way or the easiest way to index a column is just go here into the properties and set the indexed thing to yes. And you can either decide if you want to allow duplicates or not. For something like the last name, you absolutely need to allow duplicates. But if you have unique values like an order number that is not the primary key of your database, then you might also set that to no duplicates. That is something that you all know, but I'm not sure if you are familiar with this window. This is the index window, and you can do something here that some people do not really know. You can create an index spanning multiple columns. So I select the last name, and then I go into the next line here and select the first name, and this will create one index spanning these two columns here. And that creates a combined index, and that is very beneficial if you want to filter for the last name, but also want to output the first name, or if you want to filter for both values, then this is very beneficial, because even if you don't use both of them in your criteria, but only filter for last name and display the last name and first name, the database engine doesn't even need to read the table, because all the information it needs to display the data is already contained in the index. And that is a huge benefit for performance, because it eliminates one read operation. So, and this is something that not everybody using with Access knows about.
Philip, I have a question. This is Kim. Do these indexes in Access work similar to how they work in SQL Server? So for instance, if you don't use last name and you just use first name, will the index get used? Or do you need to be concerned about the order that you set up the fields?
Yes, that is universal. You need to take care of the order of fields, exactly as you said. And thank you for pointing that out. I should have mentioned that myself. If you create this index, it will be good if you search for last name. It will be good if you search for last name and first name, but it will be of no use if you just search for the first name. Then this index cannot be used, because the first column in the index is the last name. And if you only search for the first name, it does not help at all, because the combination of last name and first name is totally arbitrary for the database engine, and this index does not help at all here. And another word on the sequence of fields. If you include multiple fields in an index, and you know you will use criteria querying all of those fields, then it is beneficial to put the field with the highest selectivity first. Like if you have some sort of well, maybe I'm not really sure of a good example. If you would include the primary key in a combined index, because you want to query for the primary key and display last name and first name, always put the primary key first, because it has the highest selectivity, and it will be most efficient in narrowing down the data.
So you could do, and this is Kim again, so you could do an optional column basically to say customer sense. And you're not allowing them to search on that, but when they search by last name, you want to return last name, first name, and customer sense. So how long they've been your customer.
Yes, yes.
Okay.
Yeah, you can exactly do that. If you put columns at the end of the index and you never query for them, but just display the data, it is still beneficial because the database engine does not need to read the table to get the data that is already included in the index. And that is also exactly the same with SQL Server and other database systems. But always keep in mind that indexes also take up space and need to be maintained during update operations. For most databases that I have seen in Microsoft Access, you rather add too many indexes than too few, because we usually don't have huge bulk operations where we insert hundreds of thousands of records into a table in one big data load operation. But if you do have such operations and you are concerned about taking them too long, then you need to really question if all the indexes you created, if they really are beneficial and really need to be there, because every index needs to be maintained on update and insert operations on the table, at least if the indexed columns are included in the update. So this was just a quick excursion. Now we go back to the real database front end here and look at a couple of queries. So we have this query, and that is something that you might include in a customer search form. And my network access was interrupted. That is not really nice. I don't really know what this is about. Oh, hang on. Maybe I did something wrong here with the linked tables. Northwind backend. Yeah, bear with me for a second. I'm not really sure what has gone wrong here. Yes. Don't know why I need to confirm that. I didn't want that, obviously. So I hope things work again now. Yeah, okay, we're good now. So this is a query you are probably using a lot in any customer search form. And it's running pretty quick. It's taking only half a second, but always keep in mind, this is against a local database on my local disk, which is an SSD disk and pretty fast. So this is basically the optimum you can get here. But this is something you should avoid if possible, because this is not using the index on last name. And the problem is the wildcard at the beginning of the word. If the beginning of the search term is not really defined, and the term Schmidt can be anywhere in the name, like you see in this example, like the Goldschmidt guy here, then the index cannot be used because the index is basically a sorted, oh, hang on a second. I will not fetch a book. I had a nice example here, but it's not really working when I am not in the screen. So let's just switch that to a better way and run this query. And you see the execution time basically halved. And now the index can be used because we are looking up for the term with beginning with the search term we entered here. So this is really efficient and using the index, and it does not really get much better if we take out the like operator and the wildcards altogether. If we run this, it's a tiny bit faster, but that is not really a conclusive difference here. So this is about a quarter of a second, but keep in mind this quarter of a second can be like 5 seconds or 10 seconds if you're working on a slow network. So you should rather see it, we kind of doubled the performance of our query here by not using the wildcard at the beginning of the search term. Of course, if your users just want to type in any part of the name and find the record, then you need to weigh usability against performance. And it might still be better to use the wildcard at the beginning for usability reasons. But if you just look for performance, you should avoid like operations with a wildcard at the start of the search term. So another nice example here. We query our orders for orders that have not been sent by the shipper with the ID 6. And that takes quite some time because I bloated up the database with 2 million order records in here. So this works, but it's also not using the index because we don't say what we want as a criteria, but we say we want everything except the shipper ID 6. So the database engine cannot really say, okay, I encounter this record or I scan the index for particular records. It just has to read the whole table and then throw away all those records where the shipper ID is 6. And if we do a quick look at our shippers table, then you will see there are only 6 shippers included, and we don't want to see this one. So we can just reverse the query and write it. I can just do a new query here and write it this way. And now let's be fair and rerun this one because I told you about the caching mechanism and stuff, and it's not as intense on a local disk, but it sometimes does make a bit of a difference. Now we run this query again, but now we see a clear difference here. This is almost 2.5 seconds, and this one with listing all the options we actually want instead of saying just listing the one we don't want, this takes only 1.5 seconds. So it's significantly faster here. Because now with the in clause, the engine can once again use an index to get to the data. And of course, this basically is not the best approach to hard code specific values. This usually boils down to the shipper being having some special attribute. And I added a column here, a general parcel service. And the one with the ID 6 is the only one that has this field not ticked. So if we would improve our application design, we would rather use a query like this one to use the logic in a more maintainable way. That is basically the first query where I said not equals 6. And now I say, yeah, I want the orders where the shipper ID is not the one that's not a general parcel service. And the problem here is once again the not in. So let's run this query. And it takes a bit longer than expected. It takes 7 seconds. And this is due to the not, which once again blocks the database engine from using the index. And we will apply the lesson we just learned with the in condition and reverse this criteria here. We say not general parcel server equals 0. And now we will reverse this and use this query and say we want the shipper ID to be in those of the shippers with general parcel servers equals -1. And now we run this query. And it also is not the fastest of queries, but it takes 2.5 seconds compared to 7 seconds. And once again, it's down to the database engine being able to use the index. So one other general tip that is very, very generally usable in Microsoft Access, that is joins are usually better than subqueries. This is a subquery fetching the shipper ID. And if I compare that to a join, that is basically will deliver the same results as this query. That is essentially where we select the ID of the shippers and use them as a criteria. And here we join the orders to the shippers. And then we use this as query criteria. And in almost all cases in Microsoft Access, this join query will be faster than the subquery. So the difference here is not the biggest of differences. It's 0.3 seconds. So it doesn't make a huge difference. But in general, you can say the larger the second table, the shippers table is, the bigger will the difference between the join query, or the advantage of the join query will be much bigger over the alternative query with a subquery in the criteria. And as I've shown you, we have only 6 records in the shipper table. So this is a very, very small table. If we would use that on a table with thousands of rows, the difference would probably be much bigger. So it's also the same with this type of query, another subquery with exists. And this is sometimes faster for small tables. So it might be faster here than the join, but the difference will be really, really small. And it's actually slower. That is a bit of a surprise. I can rerun it if that makes a significant difference. No, it doesn't. So the join query here is really the best option. Sometimes for some queries, exist is a real alternative if the subquery table is really small, but you can kind of pin down the general rule. The join will be the best option in Microsoft Access. That is something you need to keep in mind. This is Access specific because it is definitely different on the Oracle database system that is much more fond of subqueries, or at least it was a couple of years ago when I last worked with it. And Microsoft SQL Server also sometimes prefers the subqueries over the joins. There you need to kind of try different approaches to find the better one. But in Microsoft Access, I would say 98 to 99%, the join queries will be faster than any subqueries to get the criteria. So this is something you should absolutely not do. And I close this for a second and reopen it to get rid of all those results and tabs we don't need anymore. Now we have an VBA function in here, formatted address, and we'll take a quick look at that. Oh, here it is already. It is, we don't need to really go into the details. It's a really, really simple function. It takes the country, state, postal code, city, and street. And depending on the country, it will just kind of format the address for an address label to print on a letter or an envelope for the postal service to kind of efficiently deliver that, because the format is slightly different. You see in the US, the city is first and then state and postal code. In Germany, we prefer to have the postal code first and then the city, and the state is irrelevant for the postal service in our country. So it's a really simple function that does just string concatenation. And what we do here, we then use the like operator to compare the formatted string to this criteria that also uses the bad wildcard operator at the beginning. And I'm going to run this. And this takes 2.5 seconds. And it is not a really efficient way to deal with data. If we use something else instead, if we go down to the basic columns here and say, okay, we compare the zip and postal code and the city, that will produce the exact same results in like 200 milliseconds compared to 2.5 seconds. And that is because the formatted address function needs to be called for every record in that table. And I said we have 200,000 customers in that table. So the database engine needs to invoke this function 200,000 times just to find out if the return value of the function matches these criteria here. And in this version, we use the criteria, but we go directly to the index database columns. So it runs really, really fast. We still have the VBA function up here in the output. So if we look at our results here, hang on, I need to make that bigger, like address labels. So we still get the formatted output without almost any performance penalty, because it will be only invoked now for the 3 records we have in here. Just 3 times invoking the VBA function instead of 200,000 times. So this makes a huge difference. And I can't repeat it often enough. Always keep in mind this is with the local backend database. where it can be directly read from disk into memory, or is probably partially already in memory and can be processed really, really quickly. If you need to fetch all that data over the network, it will not be a difference of 2.5 seconds, but probably 20 seconds or more.
Philip, quick question on the remote over network versus local and having to wildcard at both ends of the string like you have there.
Yes.
If that's a situation, and this may be beyond the scope of what you're dealing with, but would you recommend, say, building a local cache on load of the remote table and then referring that and then doing your join from that in-memory table to the remote table, or any thoughts?
Well, that totally depends. If you absolutely have to do these wildcard searches, it might be a good idea to have that local cache table and work with that. But if there is another option like this one, where you simply can split up the criteria and go directly to the database columns, to the individual database columns, and don't need the wildcards anymore, then I would always prefer this option over the cache table, because caches are great. They can improve performance hugely. But you also need to take care of maintaining the cache, and it might go out of date. You need it not only to maintain it during the runtime of your program, but you also need to maintain your code that is basically maintaining the cache. So it's more work for you and more work for the database or the application that is running. But it's definitely an option to consider if you don't see any other approach that can achieve the same results with less effort.
Thank you.
Okay, and something I see very, very frequently, and that is queries for dates. This query will return all the orders for December, the 12th month in 2020. And we run it, and it takes about 2 seconds and a bit. And I'm actually always surprised how fast this is. But nevertheless, it can be rewritten in a much more efficient way if we use real date criteria that don't need any function call, because in this way, once again, as I earlier showed with the VBA function, to process the results of, to fetch the results of this query, the database engine needs to show every single record through the year function and through the month function to determine does this record match the criteria. So if we now run this with the hard-coded criteria, it takes about half a second compared to 2 and a bit seconds. So it's once again much faster here. So, and if we want to do something like querying for the current month, then we need to use a function to get to that, and basically the date function to determine the current date. But we can still create values that kind of are processed like these hard-coded values with exact dates when we build our date using date serial. And let's quickly run this query, and it's also 400 milliseconds fast. It's in the same range as this with hard-coded values, even though we use functions here. But this function is called only once for the whole query to determine, to kind of convert our dynamic date input into a string similar to this one. And of course, the second function is also only called once. And it's not only one function, there are multiple nested functions, but they are all called only once. And so they do not impose that performance penalty. So, and I deliberately picked this example because that is something I see in the forums and asked anywhere all the time. And I see the version here where people just apply any functions to their database columns. And this works great if you have got 100 records or 1,000 records in your database. But once you go significantly beyond a small volume of data, this will basically kill off your performance. So it's really important to keep that in mind. So one last topic, just close and reopen that once again. We have this query. And it's really, really fast. It took only 200 milliseconds. But it does not produce the desired result. You see, the company name Mad Max is once written with a capital M in the middle and once with a lowercase m. And we want only the records that are for the company with explicitly an uppercase M in the middle. So we run this query, and this produces the correct results, but it takes about half a second compared to a quarter of the second of the first query. But, well, of course, correct results are more important than performance. So we have to stick to this query, haven't we? Well, there is a trick you can use to get better results or to get better performance and correct results. I combine the two criterias and now rerun this query. And you see the results are correct and the execution time is down to the quarter of a second we had with the first query. Because now the database engine can narrow down the data, the 200,000 customer records, using the index on the company name, querying for Mad Max. This does not really work that way. It will be the same if we don't capitalize the M, because the Access database engine does not distinguish between upper and lowercase when comparing the criteria. But this part narrows 200,000 records down to only 2. And these 2 are then pushed through the string comp function that can distinguish the upper and lowercase of the spelling of the company name. So this is a trick you can use to improve performance when you absolutely have to use a function in the where clause of your query.
Does the order of those statements matter?
No, not at all. The database engine will figure out what is best. I'm not really sure if there was even access, but like 20 years ago, when the optimizers of the database engines weren't as sophisticated as they are now, it sometimes made a difference in which order you put in your criteria. But nowadays, the query optimizer will figure out the most efficient way. At least it will usually figure it out. There might be cases where it fails, but that will be usually much more complicated than just the order of criteria. I can't remember any query I've ever really written in the last 15 or 20 years where the order of the criteria made any difference at all. However, it might make a difference if you would do something like a nested query where if we do something like this, so does this work at all? Yes. Most of the time nowadays, it does not make a difference in here. So here we go. It does not really make a difference if you write a query that way, but sometimes it does when the query engine doesn't really figure out that one criteria could be applied first, and then the second criteria would be would take much less effort to evaluate if it was evaluated in that order. But that is usually not something that is purely depending on the order of criteria, but sometimes you have these type of situations where this helps, but it has become very, very rare. On SQL Server, however, it might more often make a difference to kind of narrow down the data in one select and then put on an outer select on top of that derived table and then query the data. That might make a difference, but there are situations where you need to kind of try out the stuff. All other examples I showed you before are really universally applicable. While this is one where it might be better for one query, but not for the other. So you really need to try for yourself if it makes a difference. So I'm not...
Phil, what about option compare in Access? Any ideas with that?
What do you mean exactly with the option compare? The option compare for string comp is the 0 here, which is binary compare, if I'm not mistaken. It must be binary compare.
I think you can do a string compare as well.
Yes, sure, you can do the string compare. I think it would be the 0, but then you get the incorrect result because the string compare does not compare for case. That is, yeah, I should have mentioned that. The string comp function compares strings, and you have two different options. You can use the text compare, that is basically the same as you get here, or you can tell it to use binary compare. And then, of course, an uppercase M and a lowercase m are different. That's exactly the point here. Thank you very much for pointing this out.